Okay, chat. It's 9:47 p.m. but we'll do the calculator free section because I haven't done any study today. And I think I'll do calculator sim tomorrow because I'm not staying up to 12 to win this exam. So 15 minutes. I'll get my notes page up. I don't think I use it though, but I'll get it out. Anyway, then we can get started. Okay, 3, 2, 1, let's go. A bag contains 1 red marble and 4 green marbles. A single marble is drawn from the bag. Number of green marbles drawn from the bag. 0 will only be 1 out of 5. And then 1 marble is 4 out of 5. Distribution of Y. Bernoulli. Determine the mean is equal to, for Bernoulli distribution, it's just equal to P, which is going to be 4 and 5. And then my standard deviation is going to be square root of P1 minus P equal to square root of 4 and 5 out of 1 and 5. It's going to be 2 and 25. Oh, sorry, 4 and 25. 4 and 25, which will square root to 2 and 5. Make sure this is correct in my formula page. Bernoulli, yep. The above process is repeated 5 times with the green marble replaced every time of the marble. Number of green marbles drawn from the bag in 5 attempts. So then this is going to be binomial. So X is a binomial distribution where we have 5 times, and the green marble is 4 out of 5. So then probability of X is equal to 2 is going to be 5C2 times 4 on 5 squared times 1 on 5 is power of 3. Now 5C2 is going to be 5 factorial, 2 factorial, 3 factorial times 16 on 25 times 1 on 125. This 5 factorial, 3 factorial, that 3 factorial cancel out, leaving 5 times 4 on top over 2 factorial. This 2 factorial can be cancelled out, so this becomes 5 times 2, which becomes 10 times 16 on, let's times this by 5 to get it to the same denominator. So we get 80 over 125 times 1 on 125. Looks like I've done something wrong here. Yes, I've definitely done something wrong here. Selecting exactly 2 green marbles, 5C2. 3 times 2. Exactly 2 marbles. Okay, let's write this all out. 5 times 4 times 3 times 2 times 1. 2 times 3 times 2. That will cancel. Becomes 2. Here, 4 times 4 is 16 on 25 times 120. Oh, wait. No, that was all correct. Sorry, I was thinking of adding. So 10 times 16 on 25 times 1 on 125. Let's make this. Actually, we can do it like that. So let's say this 5 becomes a 2. So then this becomes 25, 2, so we get 32 on 25 squared. Do I need to know what 25 squared is? Is it 625? Yes, 625. 32 on 625. There we go. I forgot that when you multiply, the denominators also multiply. Silly me. But That is the answer, or hopefully. Question 2, a set of data values. Wait, how many marks was that? 9 marks, okay. Normally, let's see how many questions are in total. Looks like we have up to page 11. Okay. Consider the normally distributed approximately 60% of the others. Yes. If the height of a large group of women are normally distributed for a mean of that, and standard deviation that uses information, the range of 142 to 184. So 163 minus 142 minus 163 by 7. It's going to be negative 21 over 7, so negative 3 standard deviations. And then 184 minus 163 all over 7 is also equal to 3. Therefore, between lies between 3 standard deviations of mean. Therefore, 99.7% of women will have heights between this range or in this range. Therefore, statement is correct. Statement is valid. Approximately 1% of women in the group has a height greater than 170 centimeters. So then this is 1 as the above mean. Now 1 standard deviation above mean will be 50%. So probability is going to be, let's say x is greater than 170. Okay, let's do this, hold on. X is a normal, just so I really flesh out everything. And then this can be 7 squared. So the probability that x is greater than 170 is going to be equal to 1 minus 50 plus half of 68, which is going to be 34. And that's going to be 84, so this is going to be 0.16. This should be 0.5. 6. Because if I look at this, there's my 50. Here's my 1 standard deviation above and 1 standard deviation below. If all of that is 68, I know that since it's symmetric, this is going to be 34. So this is my 50 plus 34. So I get 16%. And I want a percentage, therefore 16%. Approximately 2.5% of the women are shorter than what height? So then 2 standard deviations below. Mean. Therefore, let's go 163 minus 2 times 7, which is going to be 14. So 149 centimeters. Moving on, differentiate all of that. So let's pull this out to front. It's going to be 5 times, differentiate this, that's going to be 6x squared times 2x to the power 3 plus 1 to the power 4. So that's going to be 30x squared, 2x to the power 3 plus 1 to the power 4. Power 4. Given that the derivative of g of x is equal to e 2x sine 3x, determine a simplified value for the rate of change of g of x when x equals 2. So I want the rate of change of g dash of x, so I want to differentiate this. G dash dash of x, let's differentiate the first bit, the left hand side first. That's just going to be 2e to the 2x, and again multiply by everything else, so sine 3x. Now I differentiate the right hand side, which is going to be 3 cosine of 3x, and then multiply it by everything else. So then g dash dash. Okay, we are back. My sister just came in to ask me something. Wait. Solving in pi of 2 into this equation. So then I get 2e pi sine. Actually, let's no, we will do it each. So sine of 3 pi on 2 plus 3 cosine of 3 pi on 2. And then again we have e to the pi. And I want simplified value. So let's pull this e to the pi out, and I get 2 sine of 3 pi on 2. If I'm thinking of my unit circle, 3 pi on 2 is going to be heading down. So that's going to be -1. And then cosine of that is going to be 0. So then my value is just going to be equal to -2 e pi. Determine the following cosine. So what I want to do, I want to bring this 3 in front of the integral, and I don't want to divide by 2 because I'm going to multiply by 2 on the inside. So this just becomes 3 on 2, and the antiderivative of cosine is going to be sine of 2x plus c. That is my Duolingo going. Oh wait, I'm back. I had to put my personal focus mode on, and because my Duolingo timer, alert thing went off, and then it also reminded me to put my YPT timer on, so I can log the study time. Yeah. Anyway, I think that's where we're at. So if we differentiate this, we would get that back, so that's correct. Here we have it's going to differentiate into a natural log. The derivative here is going to be 6x plus 2, which we can see is 2 of this. So let's do what we did before and half on the outside. So this becomes 6x plus 2, 3x squared plus 2x plus 1 dx. And then this becomes half of ln of 3x squared plus 2x plus 1 from 1 to 0. And then half of, let's go ln, if we sub in 1 here, these all become just 1, so 3 plus 2 plus 1 is going to be 6, minus, if we sub in 0, that's going to be ln of 1. Now ln of 1 is just going to be 0, so this is going to be half ln of 6, or ln of square root of 6. No, half ln of 6 should be fine. Moving on. The derivative is that. Find the expression for that, given that that is that. Okay. So f of x is going to be the antiderivative of this. Again, I'm going to need the derivative, so I'm going to need -2 next to the e. So I'm going to have -half of -2 e to the -2x dx, which is going to be equal to -half of e to the -2x plus c. Now f of 0 equals -2. So -2 is going to be equal to a half e to the 0 plus c. And then e to the 0 is just 1. So that's going to be -2 plus a half, which is going to be -3 on 4. Oh, sorry, 3 on 2. So you go to c. Therefore, f of x will be equal to -1/2 e to the -2x minus 3 on 2. Because this would be -4 on 2, and then if you add a half, yep, okay. Question 7. 10 shop owners in a coastal resort were asked how many extra staff they intended to hire for the next holiday season. The responses were shown below. Let's see, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you very much, that's a nice number. Okay, so then 0 only had 2, so 2 on 10. 1 had 4 on 10. 2 had 3 on 10. 3 on 10, and then there should be 1 on 10 for 3, which is good. What is the mean number of staff the shop owners intended to hire? So E of X, or E of N, is equal to 0 plus 4 on 10 plus 6 on 10 plus 3 on 10, which is going to be equal to 13 on 10, so 1.3. Oh, that was it. A 95% confidence interval for population proportion based on a sample size of 200 has a width of W. What sample size is required to attain a confidence interval of width of W on 3? So then for width W, we'll say that margin of error is equal to W on 2. So then W on 2 is equal to 1.96 square root of P 1 minus P on 200. What sample size is required to obtain a width of that? So then for width W on 3, margin of error is equal to W on 6, which is equal to W on 2 times 1 on 3. Therefore, W on 6 is going to be equal to 1 on 3 times 1.96 square root of P1 minus P on N. I know it's going to be 1 on 9, but how am I going to show that? $200 1.96 times square root of P1 minus P all over 200 times 1 on square root of 9, 96 for 1,800, and for N equals 1,800. I think that works. That works. Or you could say that margin of error is proportional to 1 on square root of N. So if margin of error equals 1 on 9 of X, 1 on 9 is proportional to 1 on square root of N, and then N equals is 1/3 of X. N is equal to 9. 9 times as large. Therefore 1,800. Question 6. A manufacturer company or company manufactures and sells an item for $X. The profit P made by the company per item sold is dependent on the selling price and can be modeled by the function of that. Describe how the profit per item sold varies as the selling price changes. Where's the maximum point? 3.25. Profit per item. Oh god. So profit per item. Increases rapidly for, let's say, 1.5 x to about 3.5. Oh no, 3.25, reaching its maximum at max profit per item. Let's call it PPI. At around x equals x is about 3.25 past x equals 3.25. PPI will start decreases seemingly decreases at a reducing rate. Decreases at a reducing rate. Decreases, but slower and slower rate. Okay. Determine the exact price of that should be charged for the item if the company wishes to maximize the profit per item. So we want to maximize profit per item, which is P of X. So P of X is equal to is it 50 ln of x on 2 so on 2 all over x squared. So then the derivative is going to be derivative of the top, which is going to be 25x times x squared minus 2x times 50 ln of x on 2. Wait a minute. Oh, that's right. So it's 50 ln of x on 2. It's going to be the derivative. Oh, I know, it's going to be the derivative of the top just times that. Okay, we have to redo this, I think. Just differentiating an ln function. So the derivative and then divided by the actual function on the inside. So it's going to be 50 times 1 on 2 over x on 2. Now that 2 is going to go to the top. It's actually going to multiply by a half, so that's just going to be 1 on x. Is that right? ln of f of x. My f of x is, I'm having a mind blank here. So f of x is equal to that. So my derivative is going to be equal to 1 on 2. So 1 on 2 divided by x on 2 is 1 on 2 times 2 on x. Yeah. Okay. and then this will be times x squared, and then derivative of the bottom, so minus 2x of 50 ln of x on 2, and then we want to divide that all by x to the 4. Now this becomes 50x minus 100x ln of x on 2 all over x to the power 4. Now let's p dash of x equals 0, and 0 is going to be equal to 50x outside of 1 minus 2 ln of x on 2. So then x equals 0, or 1 minus 2 ln of x on 2 is going to be equal to 0. So then ln of x on 2 is going to be equal to -1, so 1 on 2. Then x on 2 is going to be equal to the square root of e. So x is equal to 2 times the square root of e. I'm thinking, do I really want to differentiate the top? I don't think I do want to. Okay, let's go. Is there a smarter way I can go about this? Derivative of the half times x on 2. God, it looks like I might have to do the second derivative. How many pages are there? There was 11, right? Yeah, okay. Well, plenty of time for that then. But x has to be greater than 1.5, therefore ignore. So then p dash dash of x is going to be equal to, derivative of the top is going to be 50 minus 100 of ln of x on 2. Oh my god, this is going to be horrible. What if I do that at x equals 2 square root of e minus 0.01. P of x is going to be 50 square root of e 0.01. I'm actually not sure if they expect me to differentiate this. They really want me to differentiate all of that? Okay, I think we'll come back to it in a second. We'll finish all the other ones and then we will come back and differentiate it. Determine a simplified expression for d dx of x ln of x. Let's just differentiate the first one. It's going to be ln of x plus, and then differentiate ln of x is going to be 1 on x. 1 x on 1 on x is just going to be 1. Use answer to show that that is equal to that, which is a constant. So derivative of ln of x is going to be equal to let's do d dx of x ln of x is equal to ln of x plus 1, and then that's it. So if we integrate both sides, x ln of x dx, integral of ln of x plus 1 dx. Now the left hand side will just cancel down, so we just get x ln of x. It's going to be equal to the integral of ln of x dx plus x plus c. So then the integral of ln of x dx is going to be equal to x ln of x minus x plus c. I think that's all good. Yeah, looks all good. And then down here, these graphs, f of x equals 5 and g of x equals ln of x are shown. Determine the exact area enclosed between the x-axis, the y-axis, and the functions f of x and g of x. The x-axis, the y-axis, so I want this area. So g of x is equal to ln of x. So say ln of x equals 1, x must equal e. Actually, sorry, no, not 1, it would be 0. X must equal 1, so this is 1. Therefore, it's that. And then ln of x equals 5 when x is equal to e to the 5. Therefore, area is going to be equal to, we're going to go from 0 to 1 of 5 dx plus 1 to e to the 5 of 5 minus ln of x dx which is going to be equal to 5x. It's going to be 5x times 1, 0, so that's just going to be equal to 5 plus we'll go 5x from e to the 5 to 1 minus, and here comes, I think it's x ln x minus x, so x ln x minus x from e to the 5 to 1. So this is 5 plus 5e to the 5 minus 5 minus e to the 5 times 5 plus e to the 5 minus 1 ln of 1. That's actually plus 0. And then it's because ln of 1 is 0 and it's to be minus 1. Because when it's the second one, it'll be minus, and then it'll be plus, and then there's a minus in front. So then these 5s will cancel, these will cancel, and then we're just left with e to the 5 minus 1. So e to the 5 minus 1 units squared. I guess we can check. So 5 plus 5 e to the 5 minus 5 minus e to the 5 times 5 minus e to the 5. And here this will be minus 1 ln of 1 minus 1. Here we have 5 e to the 5 minus e to the 5 minus 0 plus 1. And then if we take that minus, it becomes minus 5 e to the 5 plus e to the 5 minus 1. Yep. And again, cancel, 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 cancel. All good. Okay, now it looks like we have to do the second derivative on that disgusting equation up here. Is this all they want? It is 5 marks though. Maximize the profit per item sold. I guess we'll do it. Might as well get started. So let's say p of x is going to be equal to 50 minus 100 ln of x on 2 plus, so derivative of ln of x on 2 is just equal to 1 on x, because 1 on 2 divided by x on 2 is 1 on x, so 100. So minus 100x times 1 on x, so it becomes 100, minus 4 on 4x to the power 3 times 50x minus 100x ln of x on 2 over x to the power 8. Then this equals negative 50 minus 100 ln of x on 2 minus 200x to the power 4 plus 400x to the power 4 ln of x on 2. Oh my gosh. And all over x to the power of 8. P dash dash of 2 square root of e is going to be e equal to negative 50 minus square root of e, so that becomes negative 50 because ln of x on 2 half of e minus 200 of 16e squared plus 400 times 16e squared times a half all over 2 to the power of 8 e to the power of 4 negative 100 minus 200, so 3200 e squared plus times 8 3200 e squared all over 2 to the power of 8 e to the power of 4. So negative 100 2 to the power of 8 e to the power of 4 is going to be less than 0. Therefore, maximum as required. Ew, that was not fun. Okay, but I think that's it. Pretty easy. I don't think we've got any of these wrong. Oh, we have 10 minutes. We might as well check. So let's see. This is a Bernoulli. Y is number of green marbles. So for a Bernoulli distribution, you will have that the mean is P. Yeah. The variance is P. 1 minus P. So the standard deviation is going to be square root of that. So 4 on 5 times 1 on 5 be equal to 4 on 25. Square root of that is 2 on 5. So yep. If it's repeated 5 times, it's 5 4 on 5. If we want to select 2 green marbles, then we have 5C2, which is going to be 10 times 16 on 25 times 1 on 125. So that's just 5 times 4 all over 2. So that becomes 5 times 2 times 16 on 25 times 1 on 125. At 5, that becomes a 5. 32, 625 on the bottom. The statement 142 is 21 below, 184 is 21 above. So again, that's 3 standard deviations between the mean. Greater than 170 cm is 1 standard deviation above the mean. So then again, that is your half plus your half of the 1 standard deviation. So that's 0.5, 0.34, which is going to be 0.84. So then we have 0.16 remaining. As a percentage, that becomes 16%. 2.5% is going to be 2 standard deviations below the mean. So 2 standard deviations below is 163 minus 14 is 149. Differentiate this, 5 times 6x squared times all of that, just the power lower, given simplified value for the rate of change of g of x when x is equals pi on 2. So we differentiated the first one, got that 2 in front, times that by sine, put the 3 in front next, the derivative of sine of x is cosine of x, and then just put e to the 2x there. Then we put pi on 2, we subbed in, we got pi sine 3 pi on 2, 3, cosine 3 pi on 2, e to the power of pi, so we got e to the power of pi times 2 sine 3 pi divided by 2, which is going to be heading straight down. That's negative 1, and cosine will be 0, so negative 2 e to the pi. We got the correct scalar factor, pulled the 3 out, got a half in there, got the 2 in there, and just simply differentiated, anti-differentiated. Sine. For this one, we found the correct scalar again. We have to multiply the top by 2. We found that was the ln of the bottom. It's the half of it. We plugged in 1, which gave us ln of 6. Plugged in 0, which gave us ln of 1. ln of 1 is 0. Because e to the power of 0 equals 1. So then ln of 1 equals 0. Or log e to the power. Well, if we found ln of e to 0 equals ln of 1, this 0 just comes to the outside. 0 times 1 equals ln of 1. But yeah, ln of 6 minus ln of 1, half of ln of 6. If all of that equals that, then blah blah blah. Found the antiderivative. Again, we needed a negative 2, so we got a negative 1/2 on the outside, negative 2 on the inside. Differentiated. All of that became a half of e to the power of negative 2x. See if we differentiate that, it becomes negative 2, yeah, e to 2x. And we added plus c, f of 0 equals negative 2. Yes, so then negative 1/2 e to the 0 plus c is equal to 2. Becomes negative 1/2. So e to the 0 is 1. So then negative 2 plus 1/2 is negative 4 on 2 plus 1 on 2. So negative 3 on 2 equals c. So blah blah blah. Minus 3 on 2. 4. 13 on 10. 1800. And then we just did this question. So d dx is equal to the derivative of the first one times that, derivative of this one times this. So 1 on x times x, just 1. Use the answer from A to show that. So we use the fundamental theorem of calculus on d dx. Because then when we differentiate this, and then we find the integral of that, that's just going to give us this function back. All of that equals that. So x plus c. Why is x plus c? put ln of x dx. Usually there's two ways you can go about it, but it doesn't look like it this way. This one, ln of x is equal to 0 when x is equal to 1, and then ln of x is equal to 5 when this is e to the power of 5. So the area is 0 to 1 of 5, and then this is 5 minus ln of x. So yeah, times 5 minus 0 minus 1 e to the 5 minus 1. Alright, 4 minutes left. I think we'll end it there. I'll come back tomorrow with calculator assumed. And time to do the calculator assumed section. I got my trusty CAS. I got my formula page. I'm surprised my CAS is not running out of battery yet. I haven't replaced it for like 2 months or something. Okay, 3, 2, 1, let's go. Consider the function f of x. Sketch the graph labeling important features. Where a is greater than 1. Okay. Let's just do like a of 2, I guess. So, oh wait, I think, does it want a general formula? Yeah, I think it does. So let's say at x equals 0, no, this needs to be at x equals 2, log a of 1 is going to be 0, and then at x equals, I can't think of any more there like that, and then there's going to be an asymptote at x equals 1, something like that. And then at x equals what else is there? I'm not sure what else there would be. 2, 0. I guess I could find it when it's equal to 1, but then that would be, the inside would need to be, so x minus 1 would need to equal a, so x would equal a plus 1. So yeah, okay, let's say that's it. Determine the value of m. If f of m is equal to 1, f of m equals 1, then x minus 1 is equal to a. Sorry, m minus 1 is equal to a, m is equal to a plus 1. Determine the coordinates of the x-intercept of, it would be, let's see, where b and c are positive real constants, x-intercept, so y equals 0, so 0 is equal to log a of x plus b minus 1 plus c coordinates. So then negative c is equal to log of a of x plus b minus 1. So then e to the power of negative a to the power of negative c, a to the power of negative c is going to be equal to x plus b minus 1. So then x is going to be equal to a minus c plus 1 minus b, a minus c plus 1 minus b, and this is 0. concentration C of a drug in the blood of a patient T hours after initial dose can be multiplied by the equation. Crisis in the blood falls below 2.5. Give it a dose. What was the concentration in the patient's blood immediately following the initial dose? 4 milligrams per liter. So you just put T equals 0 there. That becomes 1 for E. It becomes 4. 11:30 a.m. So T equals, and it's every hour, right? Yeah, T hours. So 2.5 hours. C equals, I'll say C of 2.5. C of 2.5 should be equal to, in my calculator, I'm putting 4E to make 0.05 times 2.5x. No, wait, no. 2.5, it is 3.530 milligrams per liter. And the rate of change of C at 1 p.m. dC over dt is equal to negative 0.05 of C. C of 1 p.m. is going to be 4 hours ahead. So sub in here for 4, I get 3.2749 for dc dt. So let's say at t equals 4, dc dt equal to negative 0.05 times 3.2749. It's going to be 0.1637 milligrams per liter per hour. What is the latest time the patient can receive another dose if they are to avoid being in crisis? So then 2.5 is equal to 4e negative 0.05 t. Cast like that t. Just going to do this for solve. 4e to negative 0.5x. It's 9.4 hours. Equal to 9 hours, and 0.4 times 60 is 24 minutes. So that's going to be 9 hours after 9 a.m. It's going to need 3 hours to get to 12. So 6 hours, so 6 p.m. 6:24 p.m. I always forget to do this. How many pages are there? 16. Okay. That seems kind of small for a calculator assumed. The following function is a probability density function on a given interval. After that, find the value of A. So this is a density function. So then I know that 0 to 2 ax squared of x minus 2 dx is going to be equal to 1. I'm just going to do cast. A is equal to, I'm going to do solve. I'm going to put math to integral of 0 to 2. I'm going to put y x squared bracket x minus 2 dx is equal to 1 comma y. So this is going to solve for y. And this is 0.75. Find the probability that x is greater than 1.2. So this is going to be 1.2 to 2 of, I'll do negative 3 on 4. And it's x squared x minus 2. And it's 2 dx. It's going to be equal to, I can just copy this integral down and do negative 3, 4. And I go from 1.2 to 2. This is 0.5 to 48. Find the median of the distribution. So I'm going to need to do 0 to y Negative 3 on 4. So the median is the halfway point. So when probability is less than that, it's going to be 0.5, and above that, it's going to be 0.5. I'm going to do this of x minus 2 dx equals 0.5. Maybe I should do maybe I should show that I'm solving all of these. And this will be a solve as well. Then I get down cas y equal to, so again solve, and I need this integral, and 0 to y of negative 3 over 4x over dx is equal to 0.5. Oh, because I didn't put a comma, y is equal to 1.229 or 2. I'll say give me y given that 0 less than or equal to y less than or equal to 2. Given that 0 less than or equal to y less than or equal to 2. So then from this I get that y is just 1.229. 6. Ava is flying a drone in a large open space at a constant height of 5 meters above the ground. She flies the drone due north so that it passes directly overhead, and then sometime later reverses in the direction and flies the drone due south so it passes directly overhead again. T0 is to find the moment the drone first flies above Ava's head. The velocity of the drone at time t is given by that. Directly above Ava's head. X of t is going to be equal to the integral of v of t dt, which is the integral of 2 sine of t03 plus pi on 6 dt. So I need to find my appropriate scalar multiplier. So I'm going to pull this 2 out, and I can see that I'm going to want a 1 on 3 on the inside. So I'm going to do, on the inside I'm going to have a 1 on 3. So outside I'm going to have a 2 times 3, which is going to be 6. And it's just going to be sine of t on 3 plus pi on 6 dt. So then there's just going to be 6. The integral of sine, positive sine, it's going to be negative cosine. So here there's going to be negative 6 cosine of t on 3 plus pi on 6 plus c. And then of course x of 0 is equal to 0. Therefore 0 is equal to negative 6 cosine of pi on 6 plus c. Pi on 6 is going to be, for cosine, that's a half. So c is going to be equal to 3. Let me just make sure. Cosine pi on 6 standard and radians. Oh wait. Yes, that's 30 degrees. So this is going to be 3 square root of 3. Because this is actually square root of 3 on 2. Equal to c. Therefore x of t is going to be equal to negative 6 cosine t on 3. Right, plus pi on 6 plus 3 square root of 3. Okay. What is the drone in relation to the pilot after 16 seconds? Well, I can just do x of 16 is going to be equal to, so let's do x over 3 plus pi on 6 plus 3 square root of 3 minus, given that x is equal to 0, so 16. It's going to be 0.266 or 270 meters. So since this is negative, this is going to be south. So 0.2670 meters south. Oh wait, gonna have a quick pause. I forgot to put some timers on. We are back. Timer's back on. I forgot to put my YPT timer and forgot to put my focus mode on, so it only took a second. But let's make sure. So initially it's passing overhead and going north. So this velocity, since it's positive, it's going to be positive, it's going to be north. So if I have anything that's negative, I know the direction is going to be south. 0.26. At a particular time, the drone is heading due south and it's decelerating at 0.5 meters per second. How far has the drone traveled from its initial position directly above Ava's head until this particular time? Decelerating at 0.5 meters per second. So let's see. A of t is going to be equal to, if I differentiate this, all I'm going to get is 2 on 3 cosine of all of that. So 2 on 3 cosine of t on 3 plus pi on 6, and it's decelerating, but it's heading due south. If it's heading due south, then velocity less than 0, therefore decelerating means positive 0.5 meters per second. Heading due south. So then let A of t equals 0.5, and our CAS, t is going to be equal to, let's see, solve, let's make sure I differentiated that correctly. So differentiate 2 sine of x divided by 3 plus pi divided by 6. 2 and 3, yep. So I want to solve answer equals 0.5. If I get that, t is going to be equal to 0.5974 or 18.84. Can I get this? And just that. Oh, I can say 0 less than or equal to x less than or equal to 6 pi. And that should clean it up for me. Yes, okay. Or 15.511. But let's say v of 0.5974. This is probably going to be positive. For disregard, since we need this to be flying south. Now I'll just check that v of 15.11. Okay, yep, this is less than 0, therefore heading south. So 15.1, how far has the drone traveled from its initial position directly above until this particular time? How far has the drone traveled so is this asking for distance or displacement? How far has the drone traveled from its initial position directly above Ava's head until this particular time? I think this is asking me for total distance. No, I think this is displacement. If I get this wrong and I lose the mark, I'm gonna be so mad. Wait, what if I do both? Can I write distance equals and displacement equals? No, I don't think I can. I'll say displacement. So x of 15.11 is going to be equal to, where is my 0.697 meters. That's fine because if it's just heading south, it doesn't need to be south. I think that's all good. How far has the drone traveled from its initial position? It's 3 marks. Would that be? How far has the drone traveled from its initial position? Do I want to leave this as displacement or should I do this as distance? How far from its initial position should be just a displacement. I think. Pretty sure. I'm going to leave it as displacement. The manager of a mole distribution center organization estimates that the weight x kilograms of parcels that are posted is normally distributed for mean of that and standard deviation of 1. So then let's say x is approximately a normal distribution of a mean of 3 and a standard deviation of 1 squared, which is going to be 1. So the probability that it's more than 3.7 is going to be equal to norm CDF 3.7 to infinity of standard deviation is 1 and my mean is 3. Now let's see, action continuous on CDF 3.7 to infinity of 1 of 3. So it'll be 0.2420. And what's a percentage? So 24.20%. 20 parcels are received for posting. What is the probability that at least half of them weigh more than 3.7%? I mean 3.7 kilograms. So we'll say let y equal a binomial distribution of 20. And if they weigh more than 3.7 kilograms, this is 0.2420. At least half of them. So probably that y is greater than or equal to 10. It's going to be equal to binomial CDF. And we want to go 10 to 20 of 20 of 0.2420. So action, distribution, discrete, binomial CDF 2420 0.010 0.010. Let's just do because it looks a bit nicer. 1097. The cost of postage $Y depends on the weight of a parcel as follows. The cost of 5, an additional variable cost of $1 for every kilogram, a part thereof above 1 kilogram, a cost of $12 for parcels above 4. Part thereof is this 6.5, 8, 9.5. Is that how it goes? But it says for every part thereof. So I would imagine this is like a continuous function. Oh wait, I think that means like if it's 1.1, you still just add $1.50. Okay. Maximum 4 kilograms. So we add 4.5. Yep. Probability that Y is greater than Y. Okay, so there's gonna be a lot of more CDFs. Complete the probability distribution table. So we'll say negative infinity to 1 of 3, 0.0, 2 to 7, 2 to 8. Next one is 1 to 2 of 1 of 3, 0.1359. Next is 2 to 3, 0.3413. Next is 3 to 4. Again 0.3413, and then above 4 is 4 to infinity, which is 0.1587. If I sum all these up, 9, 0.3413, 0.3413, 1587, I get 1. Okay. Mean cost, standard deviation. Okay, so I probably want to do this all in my stats table. So stats, let's do 5, 6.5, 8, 9.5, and 12. And then this is 0.0228, 0.135. I already had 0.0228 from the previous thing apparently. 3413, 0.3413, 0.1587. Calculation, 2 variable, list 2. I get that my E of X is going to be equal to $8.87. And then my standard deviation is going to be equal to $1.7474. 7474. If the cost of the package is increased by 20% and the surcharge is added for all parcels, what would the mean and standard deviation of the new cost? So let's let n equal 1.2 of y plus 1. So the expected value of n is going to be equal to 1.2 of 8.87. Is it 87? 87 plus 1. 8.87 plus 1 is going to be 11.64. And the standard deviation of n is going to be equal to 1.2 of 1.74. 7474. 7474. 2.10. Actually, for this I should just be rounding like that. So 1.75. Since this I did it in dollars. 75 is 2.10. So one reason why the normal distribution is not a good model for the weight of the parcels. Right, a normal distribution is not a good model. So one reason because then probability of x less than 0 is equal to, so let's say negative infinity to 0 of 1 of 3, 1, 3, 5, 0, but clearly weight has to be greater than 0 kilograms, therefore not a good model. Nonsense as weight. So pretty much, obviously the weight of the parcels given has to be greater than 0, but using this probability normal distribution, there is a chance that the weight is going to be less than 0. So not an appropriate model. The proportion of caravans on the road being towed by vehicles that have the incorrect towing capacity is P. Using calculus that to maximize marginal error, value of P equals 0.5 should be noted. Let's see that constant is reduced to P hat. Okay. So then let's do DE, DP, let's do equal to square root of P squared minus, P hat minus P hat squared. So DE dP hat is going to be equal to the derivative of the top, which is going to be 1 minus 2P hat all over 2 square root of P hat minus P hat squared. Differentiate that, because differentiate of x of 1 minus x. Put in standard. So 1 minus 2. Yep, so then let dE dP equals 0. 1 minus 2P hat equals 0. P hat equals half. So this is all correct. One minus 2p. Yeah. If I differentiate that again, yeah, that gets really ugly really fast. Okay. A consulting must determine P within 8% with 99% confidence. How many towing vehicles should be tested at a random check? So within 8%, so the margin of error is equals 0.04. 4 equals 99%. So then for 99% confidence, K is equal to 2. What is it? 2. Well, I can't remember. Let's do normal CDF of -3. No, sorry. Solve normal CDF of -x to x of 1 of 0 is equal to 0.99. 2.576 and assume p hat equals 0.5, therefore 0.04, 2.576 square root of 0.5 squared over n, and cast n is equal to 576 square root of 0.5 squared over x. Oh, not numbers here. So n is equal to 1036.8, therefore at least 1037. Within 8%. For this is the margin of error 0.04. Let's say this is P, make it 0. That's still within 8%, I assume. Okay. I just love to overthink these, don't I? So I'll probably be double. Within an interval of 8%. No, okay, this is definitely right. 0.08, so this is 259.21, at least 260 people. 6 months later, the consulting firm carries a random sampling of towing vehicles. Incorrect, determine the number of vehicles in the sample that have an incorrect towing capacity. So then, mean incorrect towing capacity. So therefore, P hat 342,558 all over 2. So 0.9, I think. Divided by 2, yep, so 0.4. And then here I can solve that, so the margin of error is equal to 0.45 minus 0.342, which is 108, 0.108. Therefore, K equals 2.576, so 0.108 is equal to 2.576 square root 0.45. Let's make the square bigger. 0.55, and on the bottom I have n, so then n is equal to, so 0.108 equals 2.576 square root 0.45 and 0.55 of x, 140.8, so then equal 141. Therefore, number of vehicles with incorrect towing capacity is equal to 141 times 0.45 equal to, why is that like a weird number? Okay, 63.45, that's not very nice. 42 plus 0.558 divided by 2, 45. Confidence interval, so okay, let's see, 0.342, 0.45, okay, so 0.108 is equal to 576 square root 0.45, 0.55 all over x. 63.45, so 63. That's very odd. Usually they have nicer numbers for this. I'm just not sure exactly why. It's all messed up. Okay. The table below examines the values of AH minus 1 for variables equal to 0. Complete table rounding to 5 decimal places. What is this? 2.7 to the power of 0.1 minus 1, 0.1. And this one is 1.04425. And then 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 0.99326. Five. And the next one you do is 0.72. And this is 1, 2, 1, 2. 1.00113. 34, 34. 1.00064. Ooh, 28. Alright, this is real boring. 1.03015. It can be shown what is the exact value for A for which d of x equals a of x. Explain how the above definition in the table in A support your answer. A of x limit A equals E if d of x of a of x must equal a of x, then limit as h approaches 0 of a of h minus 1 all over h must equal 1. The value for a equals 2.7, the limit is less than 0, a equals 2.8, the limit is greater than 0, but for 2.72, what is e to the power 4? Let's just get this as a decimal. I'll say here, I don't think we should talk about that. We should just say closest value for limit which approaches 0 is when a equals 2.72 which roughly equals 2.718, approximates e. I'll write the full thing here. AH over 1 equals 1 is when a equals 2.72, which approximates e. Then down here, the population of mosquitoes p in thousands, an artificial lake is measured at the beginning of the year. The population after 2 months is given by the function. The rate of growth of the population is initially increasing, it shows, and slows to be momentarily stationary in midwinter, and it continues to increase again in the last half of the year. Determine the values of a and b. P dash of d is equal to 3t squared plus 2at plus b. Then p dash of 6 is equal to 0. So in here we have 0. T squared is going to be 36. 36 times 3 is 108. 108 plus 12a plus b. The rate of population growth is initially increasing. Oh wait, the rate of population growth. Momentarily stationary midwinter. Growth of population. Increasing again in the last half of the year. What am I missing here? The rate of growth of the population is initially increasing. And then p of 0 is greater than 0. It's equal to b, so then b must be greater than 0. It then slows to be momentarily stationary in midwinter. Semi-derivative plus 6. And then continues to increase again in the last half of the year. Back. We are back. I'm still a bit lost here. Yes? I'm just going to continue back here. The rate of growth of the population initially increasing. The rate of growth then slows. So is there a second derivative here? Initially increasing. So let's find p dash dash of t is 6t plus 2a initially increasing. The rate of growth of population. So I have my population as p. The rate of growth of it is p of t. And if it's increasing, then p dash dash of 0 is equal to 2a. So 2a is greater than 0. It then slows. What is it? The rate of growth of population. Be momentarily stationary in midwinter and continues to increase again in the last half of the year. Continues to increase again in the last half of the year. So let's say p of p dash dash of 6 is equal to 36 plus 2a So if it's increasing and then coming off and then increasing again, that's a horizontal inflection point. Oh. that's probably where I'm messing up. So then at t equals 6, horizontal inflection. Therefore, p dash dash of t 6 must equal 0. Yes, I think that's probably it. And p dash dash is 6t plus 2a. Therefore, if this is 0, this 0 is equal to 36 plus 2a. A is equal to negative 18. Then b is equal to, so 108 minus 12 times 18 plus x equals 0. Solve. B is 108. What? Okay. I think that's it. Initially increasing, slows down, then increases again. And if it's a horizontal inflection point, my second derivative at that point is also equal to 0. So the rate of growth is initially increasing. The rate of growth slows down. Okay, pretty sure that's right. Oh my god, the f of x be a function. That. Evaluate each of the following definite integrals. So this becomes f of 3 minus f of o. And then f of 3 is equal to 2 minus negative 1 is equal to 3. And this is again f of 3 minus f of negative 2. So negative 2. Sorry, so this is equal to 3. Oh no, this is fine. It's for the next one that I have to take into account that it's lower, less than 0. F of negative 2. F of 3 is 2. F of negative 2 is 4. So this is negative 2. So it's equal to 0, no, negative 2, negative 2, 0, no, because that bit is the bit that's less than 0. So 0 to 3 of f of x dx minus negative 2 to 0 of f dash of x dx. I move this down. I just write here that f dash of x less than 0 given that negative 2. Therefore, take or minus integral negative integral for area. I'll take integral away. I can't write right now. But this becomes f of 3 minus f of 0 minus f of 0 plus f of negative 2. It's going to be 2 minus f of 0 is negative 1, negative 1 plus, and then f of negative 2 is 4. So this becomes 8 units squared. 14, 16. Tina believes that approximately 60% of the mango she produces in the farm are large. So she takes a random sample of 500 from a day's pickings. Is correct, and 80% produce are large. What is the approximate probability distribution of a sample proportion of mangoes in her sample? Oh, okay. So then, as n greater than 30, normal distribution, where the mean is 0.6 and the standard deviation is the square root of 0.6 times 0.4 all over 500. So we equal to 0.6 times 0.4 over 500. 0.0219. So then x is approximately normal distribution of 0.6 and the variance 0.219 squared. What is the probability the sample proportion of the large mangoes is less than 0.54? Oh, x is less than 0.58. I said 54, didn't I? Yeah. I won't write it out because I've already shown how I've done it, but normal CDF negative infinity is 0.58. 0.0219 or 0.6 is 0.1806. Tina decides to select the mangoes for her sample as they pass on the conveyor belt to be sorted. Briefly describe how Tina should select her sample. Select every nth mango. Passes along the conveyor belt. This is okay as the order which they will be random. For example, every 10th. Along the belt. This is valid or reasonable. As the order the mangoes go on the belt. I hate my pen squeak. Mangoes go on the belt is random. Therefore, every 10th mango will be random. Hint: random selection. think there's a better way to do it. So if I just tell it to select randomly, well, humans aren't very good at that. Because that's still systematic. Or should I just say, like, she creates a list, a random list of 500 numbers from 1 to the number of mangoes farmed, and select only those mangoes. Maybe I should do that. Generate a random one to the number of mangoes then select only those mangoes that correspond with one of these numbers. With these numbers. Either G6 for 6th mango. Okay, a random sample of large. Estimate the proportion of large mangoes produced from this farm. P hat equals 250 over 500, which is 0.5. Calculate to 4 decimal places. And we'll say K equals 1.96. Cas. Oh wait, I don't even need that. I'll say cas stats. Confidence is 0.95. X is 250. N is 500. Calculation interval. Proportions and interval. 95. 500. Zero point 4562. That's not equal to P, that's not equal to 5438. On the basis of a calculation, how would you respond to Tina's belief the proportion produces at least 80% or 60%? 0.6 is above 95% confidence interval. I would respond with skepticism. That every proportion large mango is at least is at least 0.6. Because it's fine if some of them are 0.6, but for every is at least 0.6, then I will start to get a bit suspicious. What can Tina do to further test her belief? Create more confidence intervals. with larger sample sizes. Okay, and this is the last one. He has a remarkable ability to handle normal range of sound levels in order to express levels of sound meaningfully in numbers that are more manageable. A logarithmic scale is used rather than linear scale. What's listening to a sound intensity 5 billion times that of a reference intensity? 130 minutes is considered unsafe. To what sound intensity level does this correspond? Then this becomes N is equal to 10 log of 5 times 10 to the power of 9 IO all over IO, which is equal to 10 log 5 times 10 to the power of 9 is equal to 10 log 10, 5 times 10 to the power of 9, 96 or 97.0 decibels. The reference has a sound intensity level of 0. If a household vacuum cleaner has a sound intensity of 1 times 10 to the negative 5, this corresponds to a sound level intensity of 70 decibels. So 7 is equal to 10 log 10 to the negative 5 over IO. Determine IO. So then 10 to the power 7, I guess I'll do it in 2 steps. 7 is equal to log 10 of 10 to the negative 5 IO. 10 to the 7 is equal to 10 to the negative 5 over IO. So that IO is equal to 10 to the negative 12 watts per meter squared. The average sound intensity for rainfall is 50, and for traffic is 85. So rain L is equal to 10 log of 50 over 10 log 10 of IR over 10 to the negative 12. So then IR is going to be equal to this become 10 to the power, so this is going to become 10 to the 5 equals IR over 10 to the 12. So then IR is equal to 10 to the negative 7. And then traffic, IT, so traffic, heavy traffic is 85. 10 log 10 of, let's say, IT over 10 to the negative 12. So 8.5, or 10 to the power of 8.5 is going to be equal to I of t over 10 to the negative 12. So traffic is going to be equal to 10 to the 3.5. Oh, negative 3.5. It's the sound of traffic, therefore IT over IR is equal to 10 to the negative 3.5 over 10 to the negative 7 about 3.5, which is equal to 3162.3 times as intense. Okay. We have some spare time, so let's start to go check through everything. We have a lot, so let's go. F of x is log a, where a is greater than 1. X equals 1 is our asymptote there. And x is 2 becomes log a of 1, which is 0. Should I do one like this, where it's like here, and this is a plus 1, 1. I'll put it there just to be generic. Determine the value of m if f of m is equal to 1. If f of m is equal to 1, then 1 is equal to log a of m minus 1. So then m minus 1 must equal a, m is equal to that. The x-intercept of f of x plus b plus c, if b and c are positive real constants. So then 0 is going to be equal to log a of x plus b minus 1 plus c. So negative c, a to the negative c, a to the negative c plus 1 minus b, 0. That's a concentration at 11:30 a.m. So that's going to be 4 e negative 0.05 times 2.5, 3.530. We have changed at 1 p.m. 4, so then 0.05 of 3.275 of 49. Make that more clear, that is 3.7. 7 milligrams per hour, per liter per hour. What was the latest time accuracy for both of there to avoid being in crisis? Falls below 2.5. So solve 2.5 equals 4e to the negative 0.05x. 9.4 hours, 9 hours, 24 minutes. 3 and 6 hours remaining, so 6:24 p.m. Okay, solve 0 to 2 of a of x. It's going to be yx squared x minus 2 dx equals 1, give me y, negative 0.75. So then here becomes 1.2 to 2, negative 3 divided by 4, equal to 0.5248. Median of the distribution. I'm going to solve that this y negative 3 on 4 equal to 0.5, give me y 1.229. Displacement of the drone. That is equal to that. So integral of 2 sine x on 3 plus pi on 6 dx is negative 6 cosine x on 3 plus pi on 6. I'm going to solve answer plus x. Negative 6 cosine of pi on 6 plus x equals 0 equals 3. Where is the drone in relation to the pilot after 16 seconds? Plus 3 square root of 3 given x equals 16 seconds is negative 0.2670, and negative is south, so south, heading due south, and it's decelerating at 0.5 meters per second. How far has it traveled from its initial position directly above Ivan's head until this particular time? So then differentiate all of this. It's 2 on 3. So that, so then solve, answer equals 0.5. Now, given that 0 is less than x less than 6 pi, 6 pi is going to be our domain. And I get that is equal to 0.9. It's heading south. How far has the drone traveled? From its initial position directly above Awa's head until this particular time. Is that until this particular time? So maybe it is distance. .11. Yeah, I feel like until this particular time. Just thinking, until this particular time. Yeah, I think it will be the Oh, if I check and it's not, oh, I'm maybe so angry. The velocity was 2 sine of x on 3 plus pi on x, pi on 6, pi on dx. See, for this makes me think it's displacement, but then this makes me think it's distance. So now, I don't know what to think. .70 meters. Okay. Divided over mole, that means, so this is going to be normal CDF, more than 3.7, so 3.7 to infinity. Standard deviation 1, mean of 3, 2420, 20 parcels. So CDF, at least half of them weigh more than 3.7. 1.01096. Everything that was correct. This was in my stats table. Calculation two-way variable frequency list 2. 8.87, 1.75. This is 1.2, 8.87 plus 1. 11.64 and 1.2 times 1.75. 2.1. Clearly nonsense is way is greater than 0, therefore not appropriate model. Determine P to within 8%. So yeah, it could be 7.9% above or below, and that's still within 8%. So my margin of error is 0.08. 0.08. 2.576 square root 0.5 squared of x. 259.21, so at least 160. This was a weird one because I couldn't find a nice number. 5/8 square root 0.55 over x. %99 confidence interval. So from OCF, negative x to x upon 0. Oh, it equals 0.99. 1.576. Because if I use 2.58 here, I actually get 141.2. Oh no, because it's not at least, so yeah, I would still around 241. 4, 5, and 63. If d dx is equal to x, then 1 approximately equal to e. Another fraction. The rate of growth of the population is initially increasing and slows to be momentarily stationary in midwinter at t equals 6. And then continues to increase in the last half of the year. So let's see, if I graph 3x squared plus 2 times negative 18x plus 108. If I graph that, the rate of growth of the population is initially increasing graph of p of t. So x to the power of 3 plus negative 18x squared plus 108x plus 2. Rate of growth of the population is initially increasing, but then slows to be momentarily stationary in winter, t equals 6. I still don't like the wording of this. of growth of the population is initially increasing. So this is increasing, meaning that the second derivative must be greater than 0. Or does it just mean that the first derivative is 0? If I differentiate this again, all I'm going to get is 6. I think this is the best answer I can get, honestly. Okay, so f of 3 to f of 0, 2 minus minus 1, that's just 3, that's nice. And f of x, so 3 minus -2 is 4, -2, x equals -2 and x equals 3. Take that into the way, so 0 to 3 is 2 minus minus 1, and then 1 is f of 0 plus f of -2. That's 2 plus 1 plus 1 plus 1. Okay. Let's see, 0.6 times 0.4 over 500 equals 219 less than 0.58. So 0.1 negative infinity to 0.58 of the standard deviation. 219 of that. 9806. Okay. And in statistics, calculation, interval, 45625438. I'm back, sorry. Someone just interrupted me. I was gonna check this one, and it says to maximize, but can I show the second derivative? Or maybe I can just show that on either side. It's so at p hat equals 0.49. The p or dE over dp hat is equal to let's do 1 minus 2 x to x minus x squared, given that x is equal to 0.49, 0.02, which is greater than 0. p hat of p hat equals 0.51 dE over dp hat is equal to 0.51, it's probably -0.02, which is less than 0. Therefore, max as required. I think that was the only other one that as I was, that was probably cut there because I started to end the recording, and then I was like, wait, did I actually go through this correctly? Because I think I went straight from here, and then I skipped over to this question immediately. So yeah, I think that's because when I first did this, I was thinking of second derivative, and obviously that's not going to work out very well because it was really ugly. So, and it does say that show using calculus, I need to maximize it, so I just guess I need to show that it's a maximum. And I just had the thought just then if I showed it, if I went over it, and if I showed it using the first derivative test, which was fine. Okay, now I'm going to stop. Welcome back, everyone. It's a little bit later in the day, but I just finished marking, and I am so happy, as we got 98.7%. We only lost 1 mark each in each of the different sections, so I feel like this section of this marking section of the video is going to be quite short. I'll just skim through everything because I mean there's not much to talk about really. There will be my exam. What were we up to? Whatever. I think this was all correct. They had a slightly nicer version of working out this equation or this question, where they just said that there was an n1 and an n. And then n over n1 would be 9, so then it would be 9n1, stuff like that. But it's pretty much what I said here. My left-hand side working is pretty much an uglier version of the right-hand side. Then we continue. The only mark I lost here was that I didn't talk about that the company would make a loss from 1.5 to 2, since it's below the x-axis, so it's going to be negative. I lost 1 mark there. The marks here were maximum at 3.25, and then past that it decreases. You didn't even need to talk about the slow and slow reducing rate. And everything else is correct. For this question, you didn't need all of this. You could have just found the answer 2 square root of e, which I thought was actually quite reasonable. Because I mean, who is gonna like, for 5 marks, I feel like this could be 4 marks in and of itself. So yeah. And then everything else. Apparently this question wasn't done very well in the exam. This was in one of the summary examination notes. And here, this was all good as well. So yeah, very quick. I just had one explanation that was wrong, which is, I mean, it happened. So I'm going to quickly move what the calculator assumed. And again, for calculator assumed, we only had 1 mark missing. And that was, we'll find it in a second, but here, we didn't need to include this bit. All we needed was the asymptote, the correct shape, and then this intercept. And that would have got us the full 3 marks. And then m equals a plus 1, all of this was correct. Bada bing, bada boom. I think the mark we lost is coming up here, yes. So this says decelerating. So what I thought was that since you're moving, so let's say left is negative and then right is positive. Since you're moving in a left direction, right, or negative direction going south, if you're decelerating, I thought, or in my brain, that makes me think that your velocity, like your speed is going down, so you're going to be heading to the positive direction, but no, they just took it in the absolute terms where if you're decelerating, your deceleration is going to be negative, or your acceleration is going to be negative. So I lost a mark there, but I allowed myself follow through there, and follow through there. FTM. And that was the only mark we lost here. Everything else was quite good. Good thing we came back to this, because yeah, you did get a mark for checking. You did get a mark for checking that this was a maximum. So thank God that we came back at the very end. Otherwise, this would have been, I think, just a 98% exam, which I mean is still really good. But we're getting higher and higher for methods, which is always nice. So yeah, coming back at the very end, nice. Secured myself 1 extra mark. I'm just gonna slowly go down here so you can see everything was correct. This was a horizontal inflection point. That was the key piece of information you had to infer. Going down. Square units. This one, yes, you did have to look at random numbers and that you select the mangoes appropriately from that random list. So I think if you said the systematic where it was every 10th mango, I would have been wrong. So good thing I changed that. So I just assume for these questions, just always make it random. Here they use, instead of, because I said skepticism that every proportion is at least that, they said that Tina is unlikely to be correct. But in the question, it doesn't ask you to say whether Tina is correct or not, or to tell Tina that she's correct or not. Is how you would respond. So I thought my answer was reasonable within the bounds of the question, so I gave myself the mark. And of course, you just got 1 mark for saying it's above the 95% confidence interval. Here was just do more random samples, make more CIs. So more random sample. Then make more CI. For these ones, I also did it correct. And I mean, yeah. Again, nothing much to show, which is always a good thing when you're going through feedback for an exam, that you don't have much to go through. So it was just my interpretation of the positive or negative signs and a missing piece of explanation, which I don't think are really concept issues. I think these are just more exam, like it was specific to this exam, that the way that this was worded in this particular instance here made me think about it in the wrong way. Which I mean, I guess you can get better at that. Obviously, you can do, but it's not as scary as like not understanding a concept. So I'm not too pressed. So yeah, we're gonna end it here, and we're gonna work on chemistry next. So let's go.